We saw that first derivative test. It's helpful in finding the local maxima and minima. That's one of the methods, but it's too lengthy. To cut short it, we are going to make use of second derivative test. So in this case, yes, we need to figure out the f double prime of x, that is differentiate f of x 2 times. And then we'll find the maxima and minima by examining both the first and the second order derivative. We'll make use of both. So the theorem is quite simple. If you have a function which is defined under an open interval and which is continuous, and we can find the local maxima and local minima by this fact. What is this fact? F prime of c is 0 at the point of local maxima, and f double prime of c can be less than 0 at this point. So let's look into this. So we have this particular slope. Here the slope is positive. Again, it's positive. Here at c it is 0, and then negative, and so on and so forth. Okay, please don't get confused with all these lines. It's very simple. We have positive slope, but the positivity of the slope keeps on reducing as we move from a to b. So basically, if this is f prime of x, which it is, so this is f of x, sorry, not f prime of x. If this is f of x, f prime of x for this can look like this. This is a possibility actually, right? So this slope in turn is what? This is negative, as you can see, right? The slope of this line is negative, and this is nothing but your f double prime of x. Again, this is f of x. I take the slope at all the points and draw another graph that would be f prime of x versus x. If I examine the slope of this line, it turns out to be negative itself. Because it's negative, we can figure out that it is local maximum. Again, this graph is f of x, and this graph is f prime of x. And I look into this graph. So this is negative, this is negative, this is positive, and this is more positive. So we can tell that the negativity keeps on reducing and it becomes positive. So for this particular graph, we will have f prime of x to be looking like this. And the slope of this line itself is positive. Agree? So slope of line is positive. This is nothing but your f double prime of x. Okay. When you figure out any slope, remember, we are looking at the derivative of that. Since this is positive, this would be minima, as you can see. Of course, there is one more case, that is your point of inflection. Now, when will we, or how will we get to know it's a point of inflection? Well, actually, let's see this. The test fails. See, f double prime of c, that's second derivative test. If it turns out to be 0, then it fails. It being 0 does not help. It does not conclude it's a point of inflection. Okay, see, this is very important. 0 does not mean f double prime of c. 0 does not mean it's a point of inflection. It can be local maximum, local minima, or point of inflection. Okay, we have to make use of, in this case, we have to go back to f of x, f prime of x, that is the first derivative test, and find whether c is a point of local maximum, local minima, and point of inflection. So whenever f double prime of c turns out to be 0, it's not helping basically. The test is not helping. Okay, so all in all, we have 3 tests, right? 3 possibility, not 3 tests, 3 possibility. So maxima, minima, and point of inflection. But yeah, f double prime of c cannot determine point of inflection. because f prime of c, if it's equal to 0, it can be local maxima, minima and point of inflection. It can be any one of this, right? Okay. Now, let's pick up an example to understand this and have a concrete understanding of what we are looking at. So this is your first graph which we had drawn, right? So let me go back to this. This is the first graph. This is f of x. This is also f of x. This is f prime of x, which I drew. And the slope of that is f double prime of x. This is the graph. So basically this is f of x, first derivative and second derivative. Agree? Second derivative is nothing but derivative of the derivative of x. Second derivative of x is nothing but first derivative of f prime of x. I hope you guys are not confused what I just said. Now, to figure out the point of maximum and minima, we are looking at f prime of c to be 0. So this is the point wherein f prime of c is almost 0. Okay, that's the best possible number I can get. And we can see this is positive and this is minimum. And that's what we saw. At the point of minimum, it is positive. F double prime of c is positive. And maximum, somewhere over here is maximum. So all we can do is just go to the point wherein f prime of c is 0. So I'm looking at this value. Okay, that's the best possible value I can get. And we can see that this is negative. F double prime of c is negative. Make that observation. And this is point of maximum. So I can zoom in a bit actually. Right, this is negative. Okay, and there is one more point actually. Yeah, this somewhere over here is your minimum. Can you see that? So f prime of c is again minimum over here. Right, it's minimum over here. We can see it's almost 0. Yeah, it's almost 0. And f double prime of c is positive value. So this is minimum. Okay, so this is a sequence of thinking. Now, let's look at the steps to kind of summarize what we're looking at. So first thing is to make use of second derivative test, we have to find f prime of x. Find the zeros by factorization. It's not only factorization, you can use any method to be honest. But yeah, factorization is the main thing. Then also figure out f double prime of x. And then substitute the values. F double prime of a. Basically, we're going to take up each point of, that is a1, a2. So those are the points which we're going to pick up. Substitute it and we will get to conclude the following depending on what is the result. So I'll give an example that will make it very clear. So this is f prime of x is equal to 3x to the power of 4, so on and so forth. So we have done this before also. It's the same example. So first derivative will give us this set of values. And then factorization. So factorization and all that I'm not going to do. I'm going to directly write the zeros of f prime of x. So those are, we have already done this before, right? So I'm not going to redo this again. -2, 0 and 1. And after this, we will figure out f double prime of x. Again, differentiate. So basically, you have to differentiate this. So this would be 36x square plus 24x minus 24. And again, we can take 12 common. Again, we can factorize this, make it a bit simpler to handle. 12 3s are 2s and 2s are. Right? This will make it simpler because we have to figure out f double prime of 0 and -2 and so on and so forth. We'll start off with -2. So clearly this is going to be 12 times of 4, 12, -4, -2, it is a value which is positive clearly, right? This is more than 0, indicating this is minimum, local minimum. Then f double prime of 0, so this is minus 24, indicating it is local maximum. F double prime of 1, that would be, so this would be 3, 5, or this 2 will get cancelled, 36, a positive number indicating it is minimum, right? So let's verify this, not with this graph, with this graph. Same expression, can you see that? And we have the same thing, right? Let me zoom in, it will be a lot simpler. Okay, now, so first is your minus 2. So let me go to minus 2. So input value is minus 2. So here the derivative, let me again zoom in a bit. Now, the derivative is 0 clearly, and the second derivative is 72. It's a positive value, and we can see it's a local minima, right? It's local minima. And as and when I move across, again I find it for an input value of 0. We have f prime of c to be 0, and second derivative we're getting a negative value, and this is local maxima. Okay, can you see that? It's very clear, right? And we have 1, I guess, right? The third value is 1. So for an input value of 1, we have f prime of 1 is 0, f double prime of 1 is a positive value. So this has to be local minima, which it is, right? Which it is. If you zoom in a bit, you can see that. Can you see that? So if I consider from, say, over here, it's reducing, 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 and after this point, it's increasing, increasing, increasing. Okay, I hope you guys got a clear picture of what we have to do. It's a very simple process. Differentiate it 2 times, and f prime of x, find the zeros, substitute it over here, and you're done. Of course, not every time this works out. For example, this is an example of point of inflection, and also I'm going to show that f double prime of c will also be 0 at that point. So this is the answer actually. Let me do this. So f prime of x is equal to 3x square, then the 0 of f prime of x is x is equal to 0 itself, right? So this is when f prime of x will be 0. So f double prime of x will be 6x, and f double prime of 0 is 0. So this point can be local maxima, minima, or inflection. So we have to go back to f prime of x and figure it out. Right, guys? So this is how it is. Now we can see that clearly over here. So this is your f prime of x, f double prime of x, so on and so forth. When you substitute those values, we'll get 0 over here and 0 over here and 0 over here. Actually, it need not be 0 over here, but anyways, we got so, because it's x cube, right? Anyways, so the point is we can't make use of f double prime of x to help us. We have to go back to f of x, look at what is happening with the graph. Since the values are all positive throughout, you can see that f prime of c is all positive values, right? So the funda is that since it's all positive, it's point of inflection. For this particular answer, it's point of inflection. So we can't make use of f double prime of x is what the point is. Okay, so that's the whole funda. We'll do more examples. So I hope you guys have understood. It's a very clear-cut steps. It's not to be confused. Yes, there's a lot of writing to do. That's the only hardship over here. If not, if you guys know differentiation well, product rule, quotient rule, chain rule, you're pretty much done. This chapter is going to be easy. And this topic is going to be easy too. Please don't miss anything, copy everything.